Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Here we can see that this is a triangle A, B, C, and D is the point on the line BC. The angles are also given. You can see we have to find out the length AB. Now kindly find out the length AB. All of you please try to find out the length AB. You have to consider the triangle in triangle ABD. In triangle ABD. You can see that two angles and one side is given. Two angle and one side is given. Whenever two angle and one sides are given, it means you can apply the sine rule to find out the third side AB, the side AB. First of all, yes, we have to apply the sine rule. Here we need to know the angle B. So angle B can be calculated by subtracting the sum of 60 and 48. So 180 minus 60 minus 48 gives you 72. So angle B is 72 degree. We got that this angle is 72 degree. Now we can apply the sine rule. The side AB over the sine 60 is equal to the side AD over the sine 72 degree. So from here, AB is equal to, after calculating this, we may get the answer. Okay, let us see that how we are going to find out the answer. This is 65 because this sine 60 will 65 into sine of 60 degree over sine of 72 degree. Now 65 sine 60 degree gives you the answer like this, and divided by sine of 72 degree, we got 59.1 or 59.2. Okay, 59.2. All the dimensions are given in meters, so we have to apply meters here. Okay, I have written the answer one decimal place. You can write 59.2. Well, now we have to find out the area of triangle ACD. The second part which you have to do, the area of triangle ACD. ACD. This area is required. ACD. This is the triangle ACD. You have to find out the area. You know that to find out the area, you can apply the formula in which sine ratio is involved. These two sides are given. The side AD and CD is also given. So this angle can also be calculated. This angle basically from 180 you subtract 60. So this is 120 degree. You can apply the formula to find out the area ACD is equal to 1 by 2 into the side 84 into 65 into sine of 120 degree. Now you can apply the values. 84 divided by 242 multiply 65 is this, and then multiply by sine of 120 degree. I got the answer 2364.2. So this is 2364 meter square. Okay, so this is the area of the triangle ACT. Next, we have to calculate in the third part, we have to calculate AC. The side AC is required to be calculated. This side, to find out this side, you can apply the cosine rule because two sides and included angle is given. So you can apply AC square is equal to 84 square plus 65 square minus 2 into 84 into 65. Remember this 2 because few students are there who don't know that in this formula 2 is applied, and cos 120 degree. Now I am calculating this 84 square plus 65 square minus 2 into 84 into 65 and then cos of 120 degree. Here I got that AC square is equal to 16741. I have to take the square root of the answer, so I got that AC is equal to 129.4 meters. Okay, I have rounded it off 129.4 meters. Now there is a part in which he has given a three-dimensional situation. Let me show you the part what he is asking you to do. Enlarging the image first of all, so that you must read the question carefully. Here a vertical tree of height 35 meter stands at A. As I showed you the triangle, that triangle is lying on the horizontal ground. From that triangle, you have to show a vertical tree at A. P is the point on the line BC. Please look at this statement very carefully, that P is the point on the line BC such that the angle of elevation from the line BC to the top of the tree is greatest. You will have to see this word greatest. Calculate the angle of elevation. Now, let me brief this situation. First of all, here you can see that the triangle is shown. This is the point A. At this point, the tree is there. I have drawn a 3D model of this triangle like this. This is the tree. This is the tree which is vertically standing. I would like to show you this is the view. Actually, this is the triangle. This is the situation here. I think so you will understand it now, that this is basically the triangle. This is the tree which is standing at A. Okay. So remember this line is the BC line. This line is the BC line. Only I have shown you D to B. So I have shown you DB. This is the DB. Here I have shown another line to mention that, remember this, whenever you are taking the greatest angle from a certain point. If I'm placing this pencil like this, let me show you the three-dimensional view like this. This is the pencil which is like this. Okay, here you can see the bottom of the back of the pencil is at the bottom and front is at the top. So basically we have to find out the angle of elevation, which where the eraser of the pencil is attached. From here we have to find out the greatest angle. So here you can see that in this situation a right angle triangle is formed. Here he is saying that there is a point P. This line from A to P, this is AP line I have shown you. And this is point A at which the tree is standing. Let it be clear. Okay. The tree is standing at A. This is the line which I have shown you, AP. Now I am the top of the tree. I am taking the top of the tree as T, although it is not mentioned here, but I am going to draw a separate diagram for this. This is the point P, this is the point A, like this. This is the point A and this is the point P, where this is the point P. Here you can see. And this tree is standing and top of the tree is T. I have not shown the top of the tree here because I cannot draw the tree here vertically. So that is why I have shown you this model of the vertical tree. So from this till this P, I have drawn this line PT. You have to find out this angle. If I am able to make triangle like this, then you will have to observe that what I am going to find out, I am going to find out this angle basically, which is from AP, and this is the hypotenuse of the triangle. Now here you can see that I don't know the length AP. AP is a perpendicular line, mean this is a perpendicular line because you know that the shortest distance from a point in line, if I am drawing a line like this and this is a point, say this is a point K, from this K, if the shorter distance will be the perpendicular distance. Always remember that is the perpendicular distance, the shorter distance. Otherwise, there may be too many lines to other sides also. These are not the shorter distance. We have to take the shorter distance. And remember this, the shortest distance will make the greatest angle. In the question, it was required to find out the greatest angle. So the shortest distance will make the greatest angle. So first of all, in the triangle ADP, in triangle, the fourth part I am going to solve. In triangle ADP, we are going to find out the side AP. AP is required, so you can apply the sine ratio, perpendicular over hypotenuse, sine of 60. We need to know AP. Okay, so AP over hypotenuse is 65 is equal to sine of 60 degree. From here, I can get 65 into sine of 60 degree. I got 56.33 meters. So this AP, this is AP, which I calculated 56.3 meters. And the height of the tree is given. 80 is the height of the tree, which is 35 meter. This is given in the question. Okay. Now you have to find out the angle of elevation. It means when you are standing at P and you are looking at the top of the tree, which is standing at A. So you have to find out this angle of elevation. Obviously, to find out the angle of elevation, you have to apply the tangent. So tangent, you can say this angle of elevation like theta. Tangent theta is equal to perpendicular over base 56.3. So theta is equal to tangent inverse 35 over 56.3. Well, here I am going to do this calculation. Tangent inverse 35 over 56.3. So I got the answer 31.8. 31.86, I am taking it 31.9 degree. So this is the complete solution of this question. Now let us move another question, which is like this. In this question, I have shown you a bearing also. First of all, you have to calculate the bearing of R from P. Bearing of R from P is required. It means you need to know this complete angle to find out the bearing of R from P. How we can calculate this complete angle? We know only this angle, which is 54 degree. As you know that bearing is always calculated from the north in clockwise direction like this. So we need to know this complete angle. We only have this much angle. We don't know this angle. Okay. So this much angle is required to be found. Remember that this is not the straight line. This is, if I am drawing a straight line, then this total is 180. Some students are saying that 180 minus 54, but this will be wrong idea because the straight line is like this. We need to know only this angle. This angle is required to be found. 54 plus this angle. This angle can be calculated with a rule which is known as cosine rule, and you people are already aware of that rule, that how we are going to apply the cosine rule. Well guys, now please apply the cosine rule. As you know that we are going to find out this angle RPQ, cos of angle R. This is equal to, well, now you can see that we have to find out RPQ. RPQ is required, this angle is required, and as you know that according to the cosine rule, 250 square plus 160 square minus 340 square over 2 times of 250 into 160. You can calculate it very efficiently. 250 square plus 160 square minus 340 square. I got this, and then this is divided by 2 into 250 into 160. I got this minus 11 over 32, and inverse cos of the answer gives me 110.1. So RPQ angle is equal to 110.1 degree. Okay. So now I can add 54 in one point this. So the bearing will be plus 54 gives you 164. So bearing will be 1110.1 plus 54, which is 164.1 degree. This is the bearing. Okay, now the second thing what we have to do, calculate the area of triangle, area of the triangle PQR. PQR is required. We have to find out the area of triangle PQR. This is PQR, which is required to be found. 1/2 into 160 into 250 into sine of included angle, which is 110. Because this angle is already calculated 110 degree, I am taking it as 110 degree instead of 110.1. Now I am going to calculate 160 divided by 280, 80 into 250, 80 multiplied by 250 into sine of 110. So I got the answer 18793.85 degree. So this is the answer in meter square. I hope that you have understood this part also. Someone, here, this is the question in which you can see that this AB is a vertical wall. Two strings are joined with it, and there is a sign like CDEF is suspended with it, and we have to find out the line AB. The AB length is required to be found. Here you can see this is a right angle, and this length AC is 64, and we have to find out this hypotenuse, and this angle is 35 degree. So base over hypotenuse, because this angle is given, so to find out AB we can apply the cos ratio, because this side is given with the angle adjacent over hypotenuse. So we can apply to find out AB. 64 over AB base over hypotenuse is equal to cos of 35 degree. So from here you can find out that AB is equal to 64 over cos 35 degree. So you can calculate it very efficiently, because this is a right angle triangle. 64 divided by cos 35. Okay, so 78.1, 78.1 centimeters. Okay, now AD, the side AD is required. To find out the side AD, you can apply the cosine rule. Mean AD square is equal to 64 square plus 80 square minus 2 into 64 into 80 into cos of 125. In this way, you can find out the side AD. So 64 square plus 80 square minus 2 into 64 into 80 into cos of 125 gives you answer 16369.4. This is AD square basically. AD square. Now to find out AD, we have to take the square root of the answer, square root, then answer gives you 127.9. It is 127.9, approximately 128 centimeter. Okay, angle ADC. Angle ADC is required. ADC. This angle is need to be. Now, so you can very easily apply the sine rule to find out this angle. You can also apply the cosine rule. I'm finding it easier to apply the sine rule. So sine of ADC over sine of ADC against this angle, the side 64, is equal to sine 125 over this side AD, because you have already calculated the side AD, which is 128. After calculating this, sine ADC is equal to, solving this, 64 into sine of 125, which I got this, and divided by 128, I got this, then shift sine, answer 24.2, 24.2, sorry, ADC is equal to 24.2 degree. Well, now FE is parallel to CD, and to CD and 40 centimeter below it. It means FE is 40 centimeter below. He mean to say that the vertical height of these two sides, the length between these two parallel sides, is 40 centimeter. 40 centimeter. We have to find out the area of CDEF. This shaded area is required to be found. This shaded area, you can see CDEF. So you can apply the area of trapezium, half into sum of parallel side, 65 into 65 plus 80, half into sum of parallel sides into height. Okay, so you can apply this rule. So 65 plus 80 multiplied by 20, I got 2900 centimeter square. So this is the answer of this part.